Hi all, meeting me again, and I'm here to explain to you guys about the problem example regarding the friction. Okay, and the problem that we want to talk about today is about we have two problems to be discussed today, and the first problem will be this problem, and this is part of your homework. Okay, and uh, in this particular problem, what is asked here is the uh, the value of the mu s, okay, the minimum value of mu s, okay, the minimum value of mu s, the minimum value for mu s in order to make the this condition not sleeping at all. So as you can see, there is a drum here, okay, there is a drum there, and the drum is pulled by force P with the angle of 30 degrees from the horizontal, okay, and the drum itself is rolling at the inclination of 15 degrees, okay, and the question there is, what is the value of the mu s in order to make the minimum value of the mu s in order to make the drum to roll, so not sleeping at all, okay, and beside that, the other question is about the value of the pulling force P and the value of the friction force F as well. Okay, so for the P, the pulling force P and the friction force F, okay, at the end, the results will be supposed to be in terms of m, the mass of the drum, okay, and g, gravitational, okay, gravitational acceleration, okay. So in order to solve this, the first thing that we're supposed to do is you have to see the whole system, and you have to see what is the condition which happening here. Okay, the condition which happening here is, you can see here the drum with fixed inner hub to be rolled up 15 degrees incline at steady speed without sleeping. Okay, steady speed without sleeping. What's the meaning of steady speed? Okay, if you recall what you learned in physics, I'm so sorry, last semester's physics and physics in your high school, okay, whenever it is in a steady speed, it means that the sigma f which is happening at that particular thing is supposed to be 0, okay, and because it's moving at an inclined angle, 15 degrees, 15 degrees inclined angle, right? At steady speeds, and without, remember, without sleeping here, okay, because there is a information about without sleeping there, okay, so we know that beside the whole things are moving there at steady speed, okay, we know as well that the whole thing rotates at a steady angular velocity as well. So when it is pulled like that, okay, so most likely the cylinder will move like that in that way, okay, but while moving it will rotates, okay, because there is a friction at the bottom, so it will rotates. So, and the rotation supposed to be in steady angular velocity, and because of that, because we know that there is no sleeping, that's why we know that it's at the steady angular velocity. We can assume as well, not we can assume, but we know as well that the condition that happening there is that sigma f is equal to 0, okay, the sigma moment there is supposed to be equal to 0 as well, because it's supposed to be moving at steady angular velocity as well, okay, so we know that this condition is happening there. Now let's try to solve this. In order to solve this, first we have to choose the best axis for us to solve this problem. Okay. For me, personally, I like this kind of axis. X direction in the inclined road. Okay, Y direction is the vertical, the perpendicular to the inclined road. Okay, then after that, after you choose that, the next thing that you're supposed to do is to draw the free body diagram. Okay, this is the free body diagram, the final free body diagrams that I already draw. Okay, you can see there. There are several forces which is happening at the cylinder. The first one is the pulling force P. Okay, because it's 30 degrees to the horizontal direction. Okay, but if I want to see what is the angle against the x, our x directions, our inclined road direction, it's supposed to be 15 degrees because the inclined road as the inclined road itself, okay, the inclined road itself is actually already 15 degrees there. Okay, the inclination of the road is already 15 degrees. So because the P here is 30 degrees, that's why the delta between the direction of the P with the direction of the inclined road is supposed to be 15 degrees. Okay, that's the first thing there. Then the next thing is we have W, the weight. The weight there is supposed to be the multiplication of M and G. Okay, I will put it as M and G there. Then what else that we have? The other thing that we have is normal force. Of course, normal force is always perpendicular to the contact. Okay, because the contact is supposed to be following this the road. Okay, and it's happening at this particular point. Okay, that's why the normal force is supposed to be in that direction, perpendicular to the contact. Okay, this one, this is the normal force. Then, because remember about this, at steady speed without slipping. So the most important thing there is without slipping. The meaning of without slipping means that it will rotates at steady angular velocity. That's why from the beginning, I assume because of the it rotates, right? In order that it makes sure that it will rotate at steady angular velocity, the friction force is supposed to be going that way because, as you can see here, actually you can assume the other way as well. Going down or going up is up to you. You can assume it like this, going up, or you can assume it the other way around as well, going down. You can do it that way as well. But if later your results will be negative, then you have to know that the actual direction is supposed to be the opposites of that. Okay, for this particular case, because I know from the beginning that there is no slipping and there will be a rotation with steady angular velocity, and because of that, sigma moment equal to 0 there. Okay, because of steady angular velocity. Okay, and because P will give us a clockwise moment, the F there, because W will not give us a moment against the center of rotation, O here. Okay, so if O is here at the center of rotation, O here, because W will not give us any moment, normal force, because it's going to the center of rotation, it will not give us moment as well. So the only one that can balance the moment due to P will be F, right? That's why F supposed to give us the opposite moment. That's why, because I don't want to have it has a negative value, that's why I direct it in this direction. Although from the beginning, this kind of thing is not necessary. So you can assume the other way around as well. So if you don't want to think from the beginning, where is the positive direction, you can just assume, okay, I want it to be going up or I want it to be going down. It's up to you. Okay. So for this one, I assume the F is going up. Then after that, for this kind of thing, okay, we have 3 equations instead of only 2 equations. Okay. In the friction case, normally in some of the number 1 and number 2, number 1, I believe number 1, homework number 1, because it's a point equilibrium, what you have is only two, sigma fx equal to 0 and sigma fy equal to 0. But for this one, this is not a point equilibrium because, okay, there is a rotation as well, and all the forces is not going through the same point. That's why it's not point equilibrium. That's why we will have another equation which is sigma moment equal to 0. That's why we have three equations, and we will use those two equations in order to solve the problem. Okay, the unknown there, okay, I'm sorry, the unknown there, okay, there are several unknowns. Okay, the unknown there, as you can see here, is mu s. We don't know the value of mu s. Then beside that, we don't know the value of the normal force. Okay, then beside that, we don't know the value of the P as well. Okay, okay, and the friction force and the pulling force is part of the question as well. So those are the things that we're supposed to solve. So the first thing that I will use is using sigma fx equal to 0. Okay, remember our x direction is inclined 15 degrees from the horizontal. So using sigma fx equal to 0, what I will have there will be this one. If going to the sorry, if going to the left is positive, that's why I have minus f, this one. Then I have mg sin 15 degrees because the angle here is supposed to be 15 degrees. Okay, and beside that, I have as well the p cosinus 15 degrees because remember that the x direction is inclined 50 degrees, so the angle between p and the x direction will be 15 degrees, so cos 15. Okay, p cos 15 is negative because it's going to the right. Okay, from those equations, we can see here that we have f as our unknowns. Beside that, we have as well p here as our unknown as well. So we have two equations. Unfortunately, two unknowns. Unfortunately, we only have one equation. So that's why I will keep it first. So this is our current equation. So please don't take a look at the equation at the bottom of the equation that I square. Okay, I give the square there. Okay, then we move to the second equation, sigma fy equal to 0. Using sigma fy equal to 0, if going up is positive, what I will have is n. What I will have is n. Then I will have as well w cos 15 degrees. Okay, and p sin 50 degrees. This one, it will be vertical, not vertical, but in the y direction. N is going up, positive. Okay, w is going down, negative. Okay, then p is going up as well, so positive. P sin 15 degrees is positive. So this is my second equation. Then, because here I have two unknowns as well, n and p, so I will not be able to solve this as well. So I will square this and I will give it a note here. So this is our current states. We will not be able to solve it. That's why we will go to the third equation. The third equation is sigma moment. Okay, in order to make it easy, I use sigma moment at this particular point, center point. Okay, at the center of rotation, O. I name it as O. Okay, and sigma moment at O equal to 0. Because of the sigma moment is at O, W multiply W, the effect of W to the moment there will be 0, and the effect of normal force there to the moment will be 0 as well. So there will be no effect of that. So the one that will affect the moment will be, the first one is P. Okay. So P cos 15 degrees multiplied by the radius here. This is the radius. R per 2 will be the radius. Clockwise, positive, this one, minus the the friction force. The friction force multiplied by R. Okay, that will be our second moment. And the value will be negative because it's counterclockwise. Okay, then it's equal to 0. Okay, and because of that, we can simplify this particular equation. Okay, by moving the F multiplied by R2 to the right. Okay, and crossing R. What we will get there will be P is equal to 2F. Okay, P is equal to 2F. So this is the end of our third equation. Okay, using this particular value, then we move to the first equation. Why we move to the first equation? Because the first equation there, okay, we have F and P as well. We have two unknowns as well, F and P. Here, in the third equation, we have F and P as well, two unknowns as well. Okay, which is the same unknowns. Both are the same unknowns. That's why by combining this and this, okay, we will be able to solve for F and P. Okay, then after substituting the value of P equal to 2F here, okay, that's why I will be able to get this particular equation by replacing P with 2F. Then I can solve for F then, okay, using, because all the unknowns here is just F, so I can solve for F. Then this is what I get for F. F is equal to mg multiplied by sin 15 degrees divided by 1 plus 2 cos 15 degrees. So that's the answer for F. Okay, then after that, I move again to the third equation. Because now I know the value of F, I will be able to solve for P, right? Because remember, P here is supposed to be twice of the P, twice of the F. So it's 2 times of the F. So this is our value of P. mg multiplied by 2 sin 15 degrees divided by 1 plus 2 cos 15 degrees. Remember that the only difference here between P and F is just this one. Because P is supposed to be 2 times of F. Okay, after getting P and F, then we'll move to the second equation. Okay, we will move to the second equation. Okay, P here, we can replace it with this one. And beside that, and here, we can replace it with F here divided by mu s. Remember that F is equal to n multiplied by mu s. Because why? This one is F multiplied by mu s. F is equal to friction force equal to normal force multiplied by mu s. It's mainly due to this one, the first equation, the question there. Okay, we're supposed to find the minimum coefficient of friction. Okay, coefficient of static friction, minimum coefficient of static friction. So in order to find the minimum coefficient of the static friction, we have to assume, okay, we have to assume there that this thing is happening. Okay, we have to assume that the friction which is happening is the impending motion, friction at the impending motion, which is the biggest friction. Because By doing that, we will get the value of minimum µs. Okay, that's why we have to assume it like this way. And because of that, okay, we can get n by doing like this, f divided by µs. Okay, because we already know the value of f, then we can get the value of n is equal to f divided by µs. As you can see here, if this is our f, you can see, right, this is our f. If that is our f, then the value of n will be this divided by µs. That's simple. This one. Okay. Then, as you can see here, the only unknowns that we have here is just µs. Okay, the only unknowns there is just µs. In this case, we already get our value of µs just by finishing this particular calculation. Okay. As you can see here, this is the final calculation. This particular calculation, right? I will write it again into this. I put the terms with the µs on the left and the rest on the right in order to solve for µs. Then by doing a simple manipulation, I will get this. Then after that, by moving this to the bottom here, okay, I will get this value. Okay, then because sin 15 degrees, cos 15 degrees, all of those have the values. By putting the values there, what we will get is this. This is the minimum value of µs. Minimum µs in order to make the cylinders not slipping at all. Okay, then after that, we can calculate for f and for p for the value. Remember that this is the value of the f. Mg multiplied by sin 15 degrees divided by 1 plus 2 cos 15 degrees. By replacing sin 50 degrees with the values, cos 15 degrees with the values, this is what we will get. F is equal to 0.088 mg. And because P is twice of F, this is what will I get for P. Okay. That's it actually. Okay. That's it for the how to solve this particular problem. Hopefully it helps. Okay. See you again in the next problem example.